Most of Russian oil deposits have already been explored and are actively developed. The future belongs to those reserves, which are hidden in the depths of the Arctic shelf. But full-scale exploration and assessment of these natural resources have been prevented not only by severe climate, but also and mostly by imperfect technologies. Hydrocarbons exploration under the seafloor cost approximately 50 times more than onshore. Developments of Seismoshelf company enabled to make a breakthrough in complete seafloor seismic exploration and reduce its cost substantially. Andrei Tulupov, one of the future founders of Seismoshelf, first thought about the prospects of developing new technologies in oil exploration at the turn of the century.
It was absolutely obvious that it was associated with great money on the one hand, that is, it was promising from an economic point of view. On the other hand, the task itself was fascinating: how to discover if the field was productive.
What is really hidden underneath the seafloor? Oil reserves, gas deposit, or waste rocks? To answer this question, an exploration well is usually drilled after a whole set of seismic investigations. Average exploration well success ratio is 0.4. It means that only 4 out of 10 wells are productive and 6 are unsuccessful. And each unsuccessful well onshore costs $1 million. On the shelf, the price of mistake is 100 times higher. First, the sea platform must be delivered to the required point, and drilling is often done at the depth of several kilometers. This requires huge amount of money. That is why increase of success ratio in sea oil exploration ensures dramatic reduction of oil companies' costs. As a physicist, Andrei Tulupov decided to promote technologies enabling to assess the results of seismic investigations more accurately. First thing he did was gathering a group of talented researchers to work on the new project.
The scientific world is a rather small place, and if you know where to search, you will find. Yes, there were certain ways from one group to another. Then I went to the Institute in St. Petersburg, where I met some guys who were trying to make the first seafloor electromagnetic station, and I realized that they were what I really needed.
Thus, Emmet Company was formed, devoted to developments on marine seismic exploration. The idea was to pass electric impulse through the Earth's crust and measure resistance of geological rocks. The higher the resistance, the greater probability that there are hidden oil reserves beneath the seafloor.
Physicists like building something big and powerful to bang at X-ray every layer at once. It turned out that from a practical point of view, this was not a good idea. We had to turn to seafloor recorders, and that's what we actually did.
Old seafloor stations used by Soviet seismologists were taken as an example. The result was several generations of electric exploration devices, but in those times, Russian investors were not enthusiastic about Tulupov's startup.
I met Andrei in 2007. He was introduced to me by my partner, Alexander Savchenkov. Andrei came to our office and started telling us about seismic exploration. It was very interesting, but quite incomprehensible. It was a totally new market for us. We were examining, studying the case for a very long time, talking to experts, very serious experts, by the way, who knew the industry inside out. Real professionals for whom operating in the field was their primary business. But unfortunately, that market did not seem clear to us. That's why we didn't make a deal with him.
Eventually, Emmet was bought by a major Dutch company engaged in seismic exploration, and Russian venture investors lost the promising project.
As for service companies, when something new appears, they react immediately, much faster than any venture fund. They track innovations rather thoroughly. Look at big service company websites like Schlumberger, Fugro, or PGS. They're always buying someone.
In the view of such events, Andrei Tulupov decided to establish a Russian service company which would do seismic exploration and become a competitor to Western players on the market. Successful experience of promoting the first innovative project played into the businessman's hands.
As strange as it might seem, the high-technology business market is not about technologies. It's about the people who develop these technologies in different ways. Designers, businessmen, investors, everything comes back to people. To be more precise, it's a market of reputation. Tulupov had no such reputation, but then developed one. The success of a previous project is a very important factor for the investment decision on the next project.
Andrei Tulupov, together with his scientific partner Mikhail Voronov, established Seismoshelf company in St. Petersburg. The company was to focus on searching for promising deposits all over the world using advanced technologies of seismic exploration. Tulupov came to New Technologies Investment Fund to the familiar investor Maxim Chekhovtsov with the business plan of the new company.
Business plan
is planning of the major lines and stages of business development, assessment of prospective risks, and strategy of building efficient business processes. Business plan is required to get financing of a project from both credit institutions and different funds. New Technologies Fund, established with participation of Russian venture company, invested $5 million into the project. Managing company of New Technologies is Alliance Investments.
Andrew came not from oil and gas industry. He was a businessman who brought a project idea from a completely different field. That's why we were delighted to learn that people like him could break through. It was important to us that this was a person who could break down walls, achieve great results. We, of course, took on his new project because we believed that if he could break through such walls, he'd be able to handle any project.
This is the most popular method of exploring promising deposits today. It involves a whole fleet of special-purpose ships. The flagship carries a spread of many kilometer ropes. They hold sensors able to intercept sound vibrations. Other ships generate seismic waves, which are reflected from the sea bottom and geological rocks underneath and are intercepted by the recorders. Geologists use the obtained information to make their forecasts. This method enables to explore a big area very quickly, but the success ratio of such investigations is not high enough. The method of complete seafloor seismic exploration, designed by Seismoshelf, enables to increase it.
Standard seismic models, which are used today, can be called the leading methods for oil and gas exploration at sea, which as a rule involve floating systems, floating bars, and transmitting sources. The disadvantage of the system is that the receiving sensors are located on the surface, where there are serious disturbances.
Such subsurface stations enable to obtain more accurate information. Such devices have already been used by seismologists before, but in more months they learn to make really small and light devices, which are not very expensive in use.
In fact, the biggest portion of spending on sea works, 50% or more, is the cost of special-purpose geophysical ships. Spending $500,000 a day for the use of such a ship shocks no one. We can work from small ships, which is important but not the main advantage. The most crucial thing is the quality of the material which seafloor recorders can gather.
Subsurface stations are located on the bottom 50 meters from each other like pieces on a chessboard. It enables to get maximum information to create a model of a small site. The stations are self-contained and can work for 30 days without breaks. Explosion wave gets through the water mass and bottom geological rocks. This reflected information is intercepted by the seafloor stations.
The accuracy of a geological decision depends on the information that's analyzed. Seismoshelf seabed stations use a 3-component sensor which records the full range of vibrations. That's why interpretation opportunities are much greater, and we can get more detailed data on underlying rocks than with conventional seismic exploration.
Experiments with seafloor stations are performed today by less than 10 companies in the world, but neither of them can offer such cheap solution as Seismoshelf.
The seafloor seismic stations that these companies offer are quite weighty, about 70 kilograms, and are settled on the seabed by special remote-controlled submarine robots. The technology is very expensive, and using special-purpose ships and robots is a very costly affair. I know that the work costs hundreds of thousands of dollars a day.
Each Seismoshelf station is not bigger than a football in size. It is kept on the bottom with a concrete anchor and floats up upon completion of exploration. It is just necessary to give a command from the ship, simple and cheap.
This arm holds the so-called tensioners. It's a non-reusable concrete anchor. And here's an electrochemical cartridge which prevents the mechanism from launching. When we need to elevate the station, we give an acoustic command. and the wire, which is built into the cartridge, burns out, releasing the mechanism and relieving the tensioner. The station has positive buoyancy, which makes it float up, and the anchor, we have to leave that on the bottom.
IT
and software have become a common platform for all technologies. Today, it's almost impossible to imagine an innovative product without IT components, and pretty serious ones. It's the same with the seafloor seismic exploration system by Seismoshelf. It is in fact a distributed network of special-purpose computers with tools for information collection and processing. A floating buoy to house this computer is really just a technical means of delivering it to the bottom.
Accuracy of exploration on the basis of data from numerous Seismoshelf stations is really high. It enables to create a detailed geological model of the contract site. This information is used to find hydrocarbon traps at a great depth, estimate the most promising oil and gas-bearing formations, and choose a place for drilling the exploration well. Seismoshelf bottom stations have already been tested in the Barents Sea, the Arctic region. Experts estimate prospective seismic exploration market, where the company hopes to get a good share, at more than $500 million, and this figure will be growing each year.